Okay, fourth and final video on structural change, reality. So we have two models, one based entirely on income effects with no rebound. That's the second one. One based entirely on substitution effects with 100% rebound. Now we need some evidence. So when there's no rebound, you really want to increase energy efficiency to bring down energy use. When there's a lot of rebound, you really need energy taxes. Now, some evidence. So what have we got here? Cumulative energy use and energy intensity plotted against cumulative expenditure when consumption products are sorted in order of increasing energy intensity. All the axes are normalized. So basically what this is showing us is that even the most energy intensive goods are only about the order of magnitude. It's pretty rough and ready, this data. But if you look at the right-hand figure, the highest peak is 20%. So the most energy intensive goods, which is like passenger air transport and stuff, it's still only 20% of the costs of the firms are going to energy. And the least energy intensive goods, it's about 2%. And that's like education and stuff like that. Healthcare. Very low energy intensity. Okay, so what is this telling us for the model, the first model based on substitution effects? Is this good news for that model or bad news? Well, we'll talk about that in the Zoom session, I guess. Let's see what the note tells us. The next figure, aggregate data for passenger miles and energy consumption in the US for private vehicles and air travel. So what have we got? It's pretty hard to see this, actually. I'm going to boost this. Actually, yeah, I'll pause the video and then have a look at this properly and then start again. Oopsie. Okay, so this is basically the first graph. This is for US data. I put this data together myself for an article I published a couple of years ago. So US GDP per cap, or is it per capita or total? It doesn't matter as long as all the data is the same. GDP, passenger miles. So the richer we get, the more we drive. But if cars are getting more efficient, we should expect the energy use. If efficiency is growing at the same rate as overall productivity in the economy, we should expect energy use to flatline, at least if it's per capita. But in fact, energy use has risen a lot over the period. Why is that? It must be because we've shifted into heavier, more powerful vehicles, right? And there's plenty of evidence for this. So engines have got more efficient, but we've chosen bigger vehicles, more powerful engines. Okay, what else do we see here? So in the second one, no, I can't see it. I'm going to have to zoom in again. Yeah, okay. So what else do we see? In the second one, the top right, we see that individual cars, SUVs, and so on get more efficient. But in the third one, bottom left, we see that while passenger miles in cars have more or less flatlined, passenger miles in other things like SUVs have gone up massively. Okay, so we've shifted, for instance, from cars to SUVs and from cars to flight. And of course, that's why energy use hasn't gone down. Okay. So it's kind of complicated. These shifts are going on, but it's kind of complicated. And that's just in one sector, that other patterns in other sectors will be different again. Okay. So what have we got? Reality is messy. We have a broad range of products consumed, none of which is all that energy intensive. So clearly our model based on substitution effects is way off, because that had 100% energy intensity against 0. But so is the model based only on income effects, in which we consume like one product at a time and totally abandon products and move on. A lot more work is needed to build a picture of past developments, and even more to predict the future. But having said all that, there's plenty of evidence, and I've been working on adding a little bit to that evidence, especially through Jonathan Stråle, a doctoral student, that income effects are super important. So for instance, air travel is growing much faster than GDP in the rich economies. So we're shifting into air travel. Is that because air travel is getting cheaper, or is it because we're getting richer and rich people like air travel? It seems to be, to a significant extent, the latter. Okay, the income elasticity of demand for air travel seems to be about 3%. Okay, whereas the price elasticity, I haven't put this in here, but the latest results Jonathan's got, the price elasticity is, for his data, for international air travel by Swedes, the price elasticity he got is 0.76. So it's not trivial, but it's not high. If income is going up by a couple of percent a year in the long run, price is maybe going down by around a couple of percent a year. But this is 0.76%, and this is plus 3%. So clearly this one is going to be far more important than this one, if the changes in income and the changes in prices are at similar rates. Okay, it gets even more complicated, because the price fall of air travel is not just driven by increasing fuel efficiency. To a greater extent, it's driven by increasing efficiency of the whole operation. Okay, and that's really bad news. So increasing fuel efficiency makes flights a bit cheaper, but saves a lot of fuel. You get some rebound, okay, given these kinds of numbers and this. Your only rebound is going to be a modest problem. But increase in efficiency of the whole flight operation is going to be terrible for energy expenditure, right? Because it brings down the price of flights without saving fuel. So that is going to be really bad news. And in general, capital intensive industries tend to get more efficient rapidly over time. So, and they tend to be energy intensive. So maybe it's more about capital efficiency increasing faster than labor efficiency that is driving the decline in price of energy intensive goods and leading us to shift into those goods. So that's just another thing to think about. Okay, and that's all I had. So I'll put some study questions together and we'll talk about this in class on Tuesday, I think. Okay, thanks. Oh, this time.